core data set itself is, half a petabyte of data.
Okay, I think we're going to begin, so if we could have your attention. First, I want to say thanks to Dick O'Neill and FERC for allowing us to come here and have this workshop talking about the grid optimization competition. So thank you, Dick. Thank you for Daniel and Tom and everybody else that's supporting us. Give you some background on the GO competition. This was initiated some time ago, and it's also in connection to the grid data program that ARPA-E has by Tim Heidel, who's here with us today. So thank you, Tim, and thanks also to ARPA-E. I think it's a really great opportunity that we have with this competition. I'm really excited about it. I hope you are. And we want to encourage you to, we want to encourage the society to participate as much as possible. If you have any feedback, you have any questions, please don't hesitate to contact us. We are very much interested in any suggestions that you have or, questions on participation. So we're going to go over in this session the grid optimization competition. In terms of the outline of this workshop that we're going to have, there will be a break in the middle. I'll give you some introduction, some background in terms of the GO competition, the timeline for it. I think what's very important is the proposal, entrant, and open entrant tracks that we have. So you'll learn about that. And then there's some other technical aspects associated to the competition itself, from the platform and the registration process, input-output file formats that we'll deal with, program submissions. But then also at the end, we're going to talk about how you will be evaluated as a participant, as well as the eligibility and rules requirements. But note is the information that we're going to be covering today, one, is going to be available on the GO competition website. So if you miss out on something, or if there's additional details, there will be additional details we won't cover in all entirety for this 2-hour session, but the website will have it. So keep in mind, go to the website. The slides will be available also later on. And then with that, I think let's move along. So introduction. What are the main points that we're trying to bring forward right now? So there's been a lot of emphasis from ARPA-E in terms of getting a modern grid, okay? But with a modern grid, you also need modern grid software. This is a $500 billion a year sector. And when you improve your software and your management systems, that can go a long way to really make a huge dent in terms of the operational efficiency and reliability of your system. And so modern grid software can really be an inhibitor or an enabler for all these emerging technologies that are coming into our modern grid. That is a real core focus of this grid competition. We want to have discovery and evaluation of these leading techniques for modernizing our software, and we want to communicate that to industry to then pull through that technology to be adopted. So we are looking at the discovering breakthrough technologies, and there's one competition we're going to start with, one challenge we'll start with. I'll talk about that more so today, but in general, it's discovering those breakthrough technologies, overhaul of a legacy management system that's predominantly out there today, and very important, fair and transparent evaluation of all these different approaches. Another thing in terms of background for the competition is that the GO competition, we have one challenge that we're starting with. That is not the only challenge. There's a lot of challenges out there in this realm, and we're going to be tackling a number of them. And that's what my next slide is going to focus on. There's a lot of issues out there today. Generally, our management systems, our models are very much deterministic. We're transitioning from bulk energy resources being flexible and predictable to bulk energy resources like wind and solar to not. And this really does call upon the modeling of stochastics to come forward in terms of understanding how a wind resource should be treated differently than a conventional power plant. We don't do a good job of that today. And this is one change that would likely come. And while the first competition challenge that we're focusing on is not on stochastics, there's a good chance that stochastics will be coming right around the corner. So if you're a fan of stochastic optimization, you should be on the lookout for that as a possibility. And we're also transitioning from thousands of assets that we have in our system to millions of assets. All of the DER resources that are coming forward, how do we manage them? How do we bring them into the system? How do we adequately represent them and utilize them? That has a big impact and feedback to the investment and deployment of DER. Okay, so this is again why modern grid software is really key and core to what we're trying to do. It may not be a more efficient device itself in terms of a DER, but it can make or break a new technology being adopted. And another topic is passive power flow controllers or limited power flow controllers. You can create a new hardware component for your grid to help you manage the everything from the dynamics to simply congestion. But until you put it into your modern management systems, it doesn't have a proper representation, you don't properly acknowledge it, you're not going to get the value out of it. So we're also interested in that aspect as well. The general message I would send is the grid optimization competition is not just optimal power flow, which is going to be a focus of challenge 1. It is a much broader effort. We're going to be tackling many different topics, and you should expect many different challenges coming this way. All right, why are we starting with optimal power flow? Okay, so challenge 1, optimal power flow. Well, if you look into a lot of the different type of applications and problems that we have to deal with in the power grid, from planning to real-time operations, OPF basically is there almost always. It is a core problem to managing the grid. And so we're starting with this classical traditional problem that's been very hard to solve for a long time, and we're trying to innovate in that realm. This is a common example of why optimal power flow is a difficult problem to deal with. We're talking about AC optimal power flow here, not a linearized approximation. This is a non-convex problem, and you can see that by this very odd-looking solution space for this very simple problem. This is a 3-bus, 3-node example. It's a network flow model. From the OR side, you could call it a network flow model. But think of the system of PJM that has 15,000 buses and 20,000 lines. This is a 3-bus, 3-line example, and yet it has this complexity. So definitely, I think it's clear as to the challenge that's there. Here's an example of the website. Again, as I mentioned, you'll find out more information beyond today's workshop on the website. I strongly encourage you to go there and start learning about it. And likewise, there almost surely there will be updates to the website before the competition, after the launch of the competition, during the competition. So it's very important to be up to date. All right. Next, I'm going to move into talking about proposal and entrance and open entrance. But before that, actually, I'll just take a pause if there are any questions. I do want this to be an interactive session. We have a few different speakers that are going to help us today. But if you have any questions, feel free to speak up and ask.
And we're going to use a mic just because we're webcasting and recording.
And one other thing just to mention, this is live broadcast as of right now, but we're also recording and it will be posted later on as well. All right, if there are no more questions at this point, moving on. There are 2 different ways you can participate in the GO competition, as a proposal entrant or as an open entrant, okay? A proposal entrant, well, there's a funding opportunity announcement that is going to be coming very soon. That FOA that will come out from ARPA-E will allow you to apply to it, and if you are selected, you are then paid to participate in the competition. You'll receive a small grant, that amount of money will, and with that small grant, you'll be obligated to participate in the competition, and you're still eligible to receive the award money at the end of the competition, okay? So, proposal entrants are those that can apply and are selected directly through the FOA process that should be coming out very soon. We've been working hard on it the last few weeks, and we anticipated it to be out, frankly, by now, but it'll be coming soon. All right? I already covered that. What we're trying to do with the proposal entrance process is to encourage those innovators out there to participate, as well as people that may not be from that may not have the general resources to participate in a general sense. Or for instance, if you're a researcher and you want to participate, you have a great algorithm, but you may need a software engineer to help you to develop a better approach so that you can compete with vendors that have already been in this business, then you may want to take this small grant and then use that to help pay for somebody to help develop your software. Okay? But one important, very important aspect, and I want to make it clear, we are not targeting only the traditional people interested in this domain. Okay? If I were to classify that, that would be power systems engineers, very much like the audience you saw from the FERC conference this week, people interested in optimization within power systems, the operations research community. We are interested in targeting a much broader community. I want to encourage people from those much broader communities to consider applying to this FOA. There are other disciplines that deal with non-convex optimization problems outside of even, the applied mathematics operations research community. There are people associated with chemical engineers that get into this space. So definitely you should feel encouraged that we are targeting a much broader audience than the traditional entities. And for that reason, again, there can be some algorithm out there that someone hasn't applied to this problem as of yet that could be a perfect fit. And that's exactly what we want to discover through this competition. All right, open entrance. So basically, if you are not selected through the FOA process and you want to compete, you are then in this other larger bucket called the open entrance. This will be all in the website and the rules document explaining this, okay? Now, you can also be an open entrant under two different types. You can be an entrant that is eligible to receive the award money, and you can be an entrant that is not eligible. So an example of that, for instance, would be a foreign company, all right? The rules will be covered later on in this workshop session in terms of who exactly is eligible for prize money, but there's going to be a large selection of people participating in the competition, some of which will be eligible for prize, some of which are just going to be trying to get bragging rights. We want all to participate to have the best understanding as to where the state of the art is for this technology. Okay? So as I said, non-eligible entrants, those are the entrants competing but not eligible for prize money, will still be placed on the leaderboard. So we're going to see whether or not, is the best algorithm from a university in the U.S. or from a university in Europe. But we are, I should say, trying to get at this time money to sponsor the entities that are outside the U.S. from different sponsors. We already have one from Europe lined up that is very much interested in doing that. And so if you're an entrant that may not be eligible as of right now for the money coming from ARPA-E, you should still stay in touch, because we could very well end up getting money that we can provide to a broader audience as well. We are working on that as of right now. Okay? And as I mentioned, there's a lot more eligibility and rules requirements associated to this that you want to see the website, pay attention to the later session of today's workshop. One thing I also want to say in terms of the open entrance, we want this to be a competition where we do not discourage people from participating in the sense that, we're going to steal your IP or something. That's not going to be the case. All right, so there's going to be a lot in the rules document in terms of if you're an open entrant, how is your IP and your software protected, okay? Here's an example, a description of how Challenge 1 is focused on optimal power flow. To be more precise, security-constrained optimal power flow. Challenge 1 is going to, again, have the open entrants that are those that are not selected to the FOA process, as well as then the proposal entrants. As of right now, we anticipate a FOA that ranges upwards of perhaps $5 million for a good selection of teams to be paid to participate for a small amount of money, roughly $250K. Okay? So again, this isn't to pay for you to have a large team, but to give you enough encouragement to participate. All right. And then one thing that's also very important is that it does not matter if you're an open entrant or a proposal entrant. Okay? All that really the distinction is here is that you are getting paid up front to participate or not. Everybody is judged equally under the same criteria. All right? That's very important. There's no different judging going on. We want to just know what the best approach is. And then at the end of Challenge 1, there is, as of right now, what we're planning, subject to change, but almost surely, the top 10 teams are going to get an award. Depending upon if you're an open entrant versus a proposal entrant, that amount of award money may come with different stipulations. So for an open entrant, that would be prize money. You take it, that's your prize money. Thank you very much for participating. There will be some restrictions associated to the proposal entrants. So since we're paying you up front to participate and then you do awesome, we may then say, and this is going to be in the FOA, by the way, that's going to be soon released, that you need to use that money to do something else for us, okay? Something of that nature. So for instance, After challenge 1, as I said, there's going to be another series of challenges. Likely the outcome is that we want you to continue to participate. Okay? Any questions?
Cost share?
Question?
Cost share?
Cost share. That will be handled in the FOA. Okay? We want the competition to be as open as possible, and so you'll see the answer on that, but almost surely it'll be waived. Okay? You'll notice here as well that it's listed that there are top 10 in each division, so that is going to be described a little bit later in terms of scoring. If you don't, we'll describe division a bit later. Okay? All right, moving on. Well, actually, here's the slide. There are 4 divisions, okay? So there's going to be 4 different ways that we're going to judge you. So this was primarily decided based upon, I would say, feedback from industry. We have lowest cost versus what's called a performance profile, as well as 2 different time steps. So based upon some feedback that was received, there are needs for SCOPF algorithms that are very fast, which is the reason for a real-time stopping criterion, and then also offline analysis that you would want to do that's a bit longer. And so what we're targeting here is to analyze and to see whether or not you have an algorithm that is very good at finding a good solution fast, but not necessarily the best, versus one that's a bit more, does a bit better at finding, getting close to the optimal solution. Okay? So time stopping criteria is one division, and then cost is another division, and with performance profiles. Basically, performance profiles is a way of measuring the robustness of your approach. How often are you able to find a feasible solution and a feasible solution that's very close to the optimum? All right? And so if you get placed in all 4 divisions in the top 10, it's additive. You get 100 times 4, $1,000. Okay? So after the end of challenge 1, you can get up to $400,000 worth of prize money. And we will be just showing the breakdown of this on the leaderboards for the Go Competition website. Right now, the Go Competition website has 1 leaderboard. It's going to be modified and changed to be 4 leaderboards. So you're going to see how you are performing in each category. Likewise, we're going to have a distinction given to you through the input file format, the input files that will tell you basically what sort of a division you should target relative to your algorithm. So you can have your program be input specific, that in this situation I want a faster algorithm, and so you set your settings of your approach such that I'm looking for a fast and least cost solution. Tim?
As an entrant, can I submit different algorithms to different divisions?
So as an entrant, can I submit different algorithms to different divisions? So that's what I was trying to just answer. So you're going to have an input parameter that's basically saying, tailor your approach to this division, right? So that if you have a great way of, if you have an awesome approach to get to get a very good solution with a longer time period, you just set your approach to do that. But then in the real time, maybe you need a really fast heuristic for this problem, and that's what you're going to initiate. So yes, you're going to have the opportunity to choose how your algorithm responds relative to the division. So that if you have the best approach for all 4, then that's great. And then you're going to show up in all 4 divisions, and you get the money from each division. Okay? And again, I would say that I think the reason that this is important is we want to send a strong message to industry and bring forward new technology. So when there is a particular entity that is only interested in Division 4, and they see who's the best performer in Division 4, they go to that person that's performing the best. Now, of course, if the top place is taken in all 4 divisions, then it's very clear that somebody has outright dominated the sector for this problem. But for the people who need a very fast and cheap approach, they will be able to see that information. And you will be able to, if you are a participant, to also sell that. I have a very good heuristic that solves this problem very well within a very short time frame. I may not win in 50 minutes, but I'll win in 10 minutes. Any other questions before I continue? No? All right, so timeline. This has been a moving target, but I will say at this point in time, the timeline is, we're relatively confident as to the rough time that this is going to come forward. The FOA will be released very soon, so be on the lookout for that. You'll have about 60 days afterwards to submit your application. This is not going to be the typical ARPA-E 20-page submission, okay? So the good thing is that your submission to the FOA is going to be 5 pages, and then 1 page of an executive summary, all right? So much shorter, much faster review times as well. We want to hear what you think is the best approach for this potential 250K grant we're going to give you, okay? Then you'll be notified. It's very important to note, one of the things we're doing is basically the release of the FOA is not the start of the Challenge 1 competition. The release of the FOA is in advance so that the people that we are selecting know before the start of the competition that they've been selected, okay? So the start of the actual Challenge 1 competition will come after basically the selections and notifications have been made, all right? So we release the FOA, you respond within 60 days, we're going to review it, we're going to notify you. Shortly after we notify the selected entities, the competition will start. And that should be roughly early fall, okay? Now, then after that, after the launch of Challenge 1, it'll go over a 12-month time period. At the very first month 0, the website is going to have publicly available data sets that you can download, and you can test your algorithm on your own computer in your own time to see how you're performing. You can also submit your algorithm to the competition website, and then the competition website will send you back, you scored to this level, okay? And then after 6 months, we're going to have a trial event. So basically a mirror image of the final event. You're going to submit your algorithm to the host website. You're not going to see the data sets in advance. We're going to test your algorithm without you seeing those data sets in advance. We're going to then rank everybody, post the scores. So after trial 1, you're going to see 4 leaderboards for those 4 divisions, and you're going to see how you're performing. Then you can go, then after trial 1, the data sets that we were withholding for trial 1 will be publicly released. You'll be able to download them, study how you did, why you didn't perform as well as you thought, and then improve your algorithm. That's going to then again be repeated at month 9 for trial event 2, okay? And then same thing for trial event 2, we will withhold new data sets, test all the submitted algorithms against those data sets, post the results, release the data sets. Then there's going to be the final event. That final event is when the actual judging will occur based upon all the submitted approaches, and that will then determine the prize winners. Okay? I want to go one step back to the divisions. So when there's trial event 1, 2, and the final event, the leaderboards will reflect this, all right? But during month 0 to month 6, the leaderboards will not be reflecting as much the performance profiles. And the reason is that to do the performance profile ranking, you need to have all of the submissions. And so during month 0 and 6, it's just on your own. You want to submit your algorithm, you submit your algorithm, and we give you a result. But for the trial events, all 4 will be represented. Okay? All right. This is just another breakdown of that the timeline. And we do have a potential challenge 2 there, but this is not official as of yet. Okay? Question, Dick.
Are you gonna give a general description of the problem you want to solve?
Yes. The problem formulation is going to come. All right. So that ends the first section of the workshop. I'll take any questions before I hand it over to the next speaker. Mustafa.
Are the codes that are submitted to the website open or no?
Are the codes submitted to the website open? No. There's a lot of legal aspects in terms of, and that'll be in the rules document for the website as well as the FOA release, in terms of all the protections that we're providing. We don't want to discourage people from participating by them fearing that they have the best approach and they're going to be releasing it to the public or to a competitor. So the answer is no. Last question, Ignacio?
Is the hardware that you're going to use to test the algorithms public as well? That characteristics?
The hardware. So hardware specs, available software specs, all of that information is on the website. Okay. Other questions? All right. So with that, then I'm going to hand it over to Steve Elbert. Steve Elbert is from P&L. P&L is the host of the Go Competition website and helping us put together the whole software platform. So he's going to help talk about the P&L side of this. Okay.
Thank you, Corey. My name is Steve Albert. I'm the administrator for the platform. The platform is somewhat divided between the open part, which is the website, it's all its information, the computational engine that does the evaluation, and external components. Your code is going to be out here on GitHub, and the results come out this way. So when you want, after you've registered, I'll come to that in a minute, you make a submission, and you tell us, where your code is, where the repo is, what the data set / time is going to be. The first part will be this original data set, which is open, but you will select, do you want to run the 10-minute version or the version with a 45-minute limit, and then some information about how we're going to control your software. So this information comes in, and is the first thing that happens is we go out with the repo information using an SSH key out, which you have established on your repo. We give them the SSH key. You can have a private key that's there, a private GitHub repo, so no one else can see it, and only people that have the private key. You have the public key, so we have the private key. We can access that. We make a clone of your repo. That goes into a Docker container. The data set goes into the Docker container. The various libraries and the control scripts go into a Docker container. Then it's launched within a time limit. And there's actually going to be a couple of different time limits. You get to solve the base problem within the time limit, the 10 minutes or the 45 minutes, and then we give you extra time to solve the contingency parts of the problem. And that portion is not actually timed, but there are limits to how much time you can have in that. They'll be more generous though. So after your code is run, you will have to present us with a solution in a specific format. That solution, along with the initial data set, goes into the evaluation program, which calculates the objective value and all the constraint details. That information goes into the scoring algorithm. The score and where your results are go back to the website. So on the website, you'll get a link to basically an FTP site, a very high performance FTP site that has that submission in terms of will be a tarred compressed file that has your solution, our evaluation results, and the scoring information. So all the information that we used to evaluate your code will be given back to you. For the registration, you obviously need to register with us. We need your username, an email address, your first and last name, phone number, a display name that will be used publicly on the website if you don't prefer not to use your actual name, organization that you belong to, your position, country of origin, citizenship, and you need to accept, of course, the terms and conditions as in any software agreement. You can also tell us something about the programming languages you would like to use, and this is where you go to change your password, and if your phone number or something else changes during the course of the competition, you can change that. The software environment that we are currently working with, and we are open to additional suggestions. I believe we can support more than this. Right now, if you can give us C++ code, we can make the file using GAMS, Julia, Jump, Java, Scala, Python, MATLAB, MATPower. These are all wide open code, so that that we can we can see what your algorithms are. If you're worried about us, you don't trust us, and you want to really obscure what you're doing, you can submit Linux binary executables to us, and those are a little bit touchier to work out, but work with us, and we've done this several times already with some test groups, and so we think we can do that. The solver library. One of the things about the Docker container, that has absolutely no external access. So if you have code that requires a license key from a key server, it's not going to be available. So all your code has to be packaged inside and runs in a standalone mode. Now, to help support that, we've got licenses from some of the common software solvers libraries, and if you have a favorite that it's not on this list, talk to us. We'll see if we can get it. There's even options. I think that Corey's indicated that they would be willing to pay additional license fees, but these licenses then become available to anyone in the competition who wants to use them. And of course, keep checking the website for the current versions. As new versions come out, we try to keep them up to date, and there are various restrictions on the kinds of environments that are available. Other resources, the information. There's going to be lots of challenge-specific problems out there. The problem definition, the input files in their format, the output files in their format, how we do the evaluation, how we do the scoring, and then there's the leaderboard. There's lots of also general background information about how the whole project came about. There are general references about getting started, the list of solvers, languages, details about the hardware for the platform, details about how to access and use GitHub, details about the Docker, and how to register, create a team, and make a submission, and of course the rules. We also have some keep in touch. We have FAQs, a forum, various just news releases, and a set of definitions. So there's lots of information out there that's constantly changing as the project goes forward. So, questions? So, Jesse? Jesse's going to tell you about the input and output files as we understand them at the moment. Thanks, Steve.
I'm Jesse Holzer, also from PNNL. So I'll tell you about input and output data files. The input files are everything that you need to completely formulate one instance of the competition problem. The output data is everything that we need to completely evaluate your solution. So the input data consists of five files. They are in just regular text, and the main one is this .raw file. It contains information on buses, loads, shunts, generators, lines, transformers, the sort of typical power flow data. This ROP file contains information on generator costs. There's this file INL, it stands for inertia. And that contains, it contains one piece of data that we need to formulate the problem, the generator participation factors. And then there's a file that defines each contingency. So this is a security constrained optimal power flow problem. So we've got some security contingencies, and they are defined here. Each contingency is either a generator outage or a line outage or transformer outage. So it's a pretty simple format here. And there's one last file, and that contains various parameters that you'll also need. Penalty coefficients, indicators of what sort of time limit you should be working towards. All of these data files are similar to formats that are common in industry, except I suppose for this last one, which we made up. We will be providing a complete specification of all of the fields that we're using in each of these files. So in many of these files, there are fields that we're not using. We'll tell you exactly what we're using, what we're not using, and we will also provide Python code for reading the input files. We have been doing much of this work in Python, and so you'll have that as a model. You can use it if you like, or you can write your own parsers. And then the output data for providing a solution consists of two files. So again, this is a security-constrained optimal power flow, so your solution contains an operating point in the base case where nothing goes wrong with the power system. And it needs to also contain information about everything that happens in each contingency, should that contingency occur. So our solution 1 file contains the base case operating point, and then solution 2 contains a representation of the solution in each contingency. And it has to be, it's got to be enough information that we can completely reconstruct and evaluate your solution. But there are some variables that you can imagine are contained in your solution that we don't need because we can derive them. All of that will be described in detail in a complete specification. These files, we're planning that these files can be provided in one of two possible formats, either in plain text or in HDF5. In particular, the solution 2 file is expected to be fairly large. A little bit of detail on the solution files themselves. So in the solution file, you'll need to provide for each bus the voltage magnitude, voltage angle, and the susceptance of any switched shunts at that bus, total susceptance of all switched shunts at that bus. For each generator, you'll need to provide the real and reactive power outputs. For each contingency in solution 2, you'll need to provide a bus section, a generator section, and a section on the whole system. The bus section, similar to the base case, generator section, similar to the base case. And then this final section, the system section, tells you it has just one scalar, this delta K. You can think of that as the total amount of real power that needs to be made up in a contingency due to loss of a generator or change in losses from line outages. It's not really exactly that, but that's one way to think about it. It is anyway a scalar. With all this data, we can completely reconstruct your solution and evaluate all your constraints and the objective function. One last thing to note about solution 2 is it's ordered first by contingencies, so that in theory, if you like, you can process one contingency at a time, and you don't really have to be writing all contingencies all at once. This may be helpful for some teams. Again, a complete specification of these formats will be available, and also Python code for reading the output file. So we will be needing to read your output files, and we'll provide code so that you can see exactly what we're doing with that. A little bit about our general procedure that will be followed when we evaluate your code. So, roughly, your code should read our data files, do something, solve the problem, and then write these two solution files, solution 1 and solution 2, and then we'll read your solution files and evaluate your solution. The solution 1 is the one that needs to be returned in a specific time, so either 10 minutes or 45 minutes, depending on the context. Solution 2, well, there's also a time limit on solution 2, but it's really long. It's long enough that you should have no problem completely solving each contingency. So the idea of this procedure is that we really want to reward or incentivize, anyway, algorithms that are able to get a good solution in the base case because they are able to avoid fully solving each contingency. So in detail then, our procedure is, if you're doing this in Python, we're going to run a myPython1, so you'll provide us this Python script. We'll run that with the time limit T1, either 10 minutes or 45 minutes. Then we'll read your solution 1. Then we'll run your myPython2 with this much longer time limit, and we'll read your solution 2. One key thing to note here is that you should be done producing solution 1 after this step 2. So you can still write solution 1 afterwards, but we won't read it. We're going to read it just this one time. And I won't go through this, but when these slides are made available, this is all the nomenclature that is referred to in this set of slides. Okay, any questions?
Mustafa?
So how is the contingency part not, like, the way I see it is that the contingency constraints are really connected to the base case optimization, so I don't understand, like, the giving more time to the contingency part of the code. What does that do?
The philosophy here is that you may be able to take 10,000 contingencies and quickly screen them in some fashion so that you know that there are only 100 of them that you really need to model closely. Then you run your model on those particular contingencies. You come up with a base case solution, and you write that. And maybe that takes you 45 minutes. But then you've got quite a bit longer to actually produce a solution for all of the individual contingencies, and we need that solution in order to check that your base case solution makes any sense. In order to check the constraints and objective value of even your base case solution.
Tim had a question.
No, I'll just add a little bit of historical context there. I mean, the original theory was, okay, you give us a base case solution, and then the competition platform tries to run a power flow, find the solution under contingency K, and it fails. And did it fail because your solution is bad and there is no solution under that contingency, or did it fail because the particular power flow algorithm we were using happened to not converge in that particular case? And we wanted to avoid sort of arguments with competitors whereby I know my solution is valid, you weren't able to find it. So we said, well, okay, give us the solution in the contingency case. We can just check that it's a valid solution, right? Solves the system of equations, and then we're all set.
One other note on that. So you get a base case solution. There are precise, requirements for the movement between base case and post contingency. So if you give us a base case solution and then you do not satisfy feasibility in the post contingency, well, then you're out of luck, or you're going to get penalized, right? So if you take that risk, as Jesse was saying, I know that these 90% of these contingencies are not critical. If you want to solve these large-scale problems in real time, you need to have something of this nature, or at least as of, relative to the state of the art today. And so if you're good at knowing which ones are needed, which ones are not, okay, and you focus on the ones that you do need, then you should be rewarded as a result of that, okay? And if you go wrong, then you're going to get penalized, There's the other aspect that, you know, if all of the writing time it takes to produce all of the solution2.txt file, which is going to be a large file, that would be, you know, convoluted in the process of the evaluation. So, Erminio?
It's not very clear for me after the discussion, if the base case has to be safe for all contingencies or just for a subset of contingencies?
No, your base case, your solution 1 and solution 2 text files will be completely combined to give us all visibility of pre and post contingency for the actual data we give you. And if we give you 20,000 contingencies, it has to be against those 20,000. Okay? It's just how we are scoring, how we are evaluating it based upon this time limit, right? Because what's the point of producing, you know, a solution 2 text file for 9,000 contingencies that all of us in the room would agree, okay, it's relatively easy to find a solution, so it's less sensitive, okay? But we're still going to do that to make sure that, again, it's valid for all listed contingencies.
Yeah, of course, writing the results for all contingencies is going to take a long time. But
yes.
Solving the mutation process, the problem for all contingencies, that has to be taken consideration, and all the contingencies must be evaluated.
Yes. Well, in the end, the scoring is exactly that.
Yeah.
Okay? Other questions? All right. Well, if there are no more questions, then I am the next speaker again. So, coming to Dick's question about the formulation. We wanted to give you some intro to the competition, what encourages you, the prizes. Now we're getting into the technical discussion, okay? So, as mentioned, this is a security-constrained optimal power flow. It is an AC optimal power flow. One thing I want to mention, this will be stated in the FOA. For the FOA applicants, we are not interested in methods that do not consider how to handle security constraints. You talk about something that is only for an AC OPF and you don't get into the security constraint issue, that's going to be a non-responsive application. Okay, that's going to be listed in the FOA. Another way that I want to describe this, okay, because again, this is not just for the people who are domain experts in optimal power flow. This is a non-convex optimization problem. It involves, if you want to reformulate, a mixed integer programming formulation, okay? So this is, I would say, at the cutting edge, if you come from the optimization community, non-convex mixed integer program. There are complementarity constraints that you're going to find I'm going to go over next. There are many complexities that come from this, okay? And even though it is a non-convex mixed integer program, you will be judged on that formulation. If you choose to linearize it and get a solution, as long as it fits, again, to the formulation that's official, that's fine. If you want to apply a decoupled power flow technique, that's fine. You want to do a convex relaxation, that's fine. In the end, we don't care what approach you use, but the scoring is going to be based upon the formulation. Okay. So, what is inside this formulation? As I mentioned, it's an AC optimal power flow with security constraints. There are some constraint relaxations inside of it. All right? The constraint relaxations is basically, we do model some constraints as a soft constraint. And the rationale behind this is how do you score issues associated to rounding errors, precision of the computer, or just infeasible solutions. Somebody comes up with an infeasible solution. How does that get scored? So constraint relaxations are an important feature that you should pay attention to. When do they apply and when do they not apply? Because if they don't apply and you violate a hard constraint, then you're going to get put into a bucket of you got an infeasible solution. And you're going to be judged and your score is going to be reflective of a penalty through that, okay? The real power response post-contingency is going to be a representation of complementarity conditions. You're going to see this momentarily. Likewise, reactive power modeling. This is what is known as PV/PQ switching, okay? I'm going to go over in this session a simplified formulation of the official formulation. You need to go to the website to see the full-fledged formulation, okay? In the FOA that will be released soon, there will be a simplified formulation. You need to go to the website for the official formulation, okay? The objective function. It's going to have a piecewise linear generator cost function, just like all of our markets have today. There's going to be a probability that we define relative to having no contingency occurring. And there's also a probability defined based upon contingencies occurring. Then you're going to have, relative to the base case, relaxations and the post-contingency relaxations on node balance constraints. You're going to have penalties. What this represents, again, is that if I don't satisfy flow in equals flow out, a very common network flow constraint, you're going to have a penalty. So if your real power is insufficient at that location or your reactive power is insufficient, you are going to get penalized. These penalty prices are going to come directly from ISO existing practices today that are in all of the market management systems, all of the market environments today. They vary based upon what prices they assign, but every entity has a limit basically on the LMP, locational marginal price. That's essentially driven through the node balance constraints, okay? And this is going to, again, be there. The relaxation associated with the pre-contingency node balance, post-contingency node balance. There's also going to be relaxations relative to the limits on the lines, or you could say limits on transmission elements. You don't only have lines, you also have transformers. And they're going to have their own penalty prices as well, driven by industry practices and slack variables. Basically, the node balance piece of it, this is essentially an infinite generator of infinite capability at every node in the network. So I will say this one thing, a feasible solution to the relax problem always exists. And so if you can't get a feasible solution, you have a not a very good approach, okay? Now you also have relaxations on the line limits as well. There are not going to be relaxations on voltage limits, where there's going to be very precise procedures as to how we evaluate somebody with a rounding error for a voltage limit. Frankly, the best thing to do with a hard limit on the voltage for a bus is build in, frankly, a very small buffer relative to your rounding, because the structure of penalty that we're going to impose for infeasible solutions will push your objective function up dramatically, as opposed to the fact that if you're 1.099999, the impact on your cost for that solution is very minuscule relative to being tight at 1.1, okay? So that's some suggestions, all right? And then we're also treating all contingencies equal relative to the number of contingencies that we have. We're using index K. That's the objective function, all right? This is what you're predominantly scored on relative to the lowest cost solution. Relaxations, I mentioned node balance equations, and then the transmission assets, line limits, transformer limits. As I mentioned, dictated by market rules, and we're doing this for a fair and transparent evaluation of when there's a rounding issue involved. We don't want to put in a buffer with rounding and say you're allowed to have, 10 to the minus 8 error in your rounding because someone can game that. We're taking that away. There's basically then a linear penalty relative to your off of these constraints, okay? Transmission contingencies. This is a security-constrained optimal power flow. The security-constrained piece of it is referencing N-1 reliability mandated by a NERC, okay? We're looking at single line or transformer outages. Those are the contingencies that you're going to be given. You're not going to be given multiple contingency events, N-K. It's only going to be N-1, okay? The predominant way of treating transmission contingencies, since you don't lose generation, is that you don't move your set point for the power generation coming from your generation fleet. That's going to be predominantly the rule that you're going to find in the formulation, with one exception. This is an AC model. You lose a transmission line, losses change. And so, therefore, there has to be a change in overall generation to make up for change in losses. That's going to be dictated by a participation factor governing your generators. All right? Now, I'm not going to get into the complexity here. I'm going to talk about it more in the generator contingencies, but this is basically also a representation of complementarity issues that you're going to find in the next coming slides. Dealing with this complementarity issue, there are approximations that you can take. I would say that if I was on the competition, I will definitely take a different approach to solving the transmission contingencies than the generator contingencies, relative to how influential those complementarity issues are. I think it's easier to predict, I'm saying, with the transmission contingency. All right, generator contingencies. It gets more complicated. Again, single outages only, so single generator outages. you're going to have a participation factor. This is reflective of common practices today. You take a real-time contingency analysis tool in your energy management system, it's governed by a participation factor. If you don't know, a participation factor is basically an offline assessment, judgment call by your entity to say, I expect you to provide a certain fraction of the amount of energy I need after an event. So if I lose a 1,000 megawatt nuke unit and you're going to provide 10% of that, then you're going to inject 100 more megawatts ex post. That's the purpose of a participation factor. I will make one important note here as well. You want to see how this connects to the industry. California ISO is changing its market structure to introduce generator contingency modeling in their day-ahead integrated forward market, IFM, such that they rely on participation factors within their security-constrained unit commitment model. Okay? In this security-constrained optimal power flow model, there's a very much similar situation here. This is going to be a bit more complex, though, because California ISO is not making sure that if I'm already operating at Pmax and you're expecting 100 megawatts from me, their model as of right now proposed will violate that. And they're okay with that, but we're not going to allow that. That's where the complementarity issues come into play. There are 3 cases for your real power generator response. You are operating at 100% of your capacity. I'm anticipating with the participation factor that you're going to inject something, but you cannot. That puts you into 3 different cases. You're either able to provide the participation factor as assumed, or you're at you reach your Pmax or you reach your Pmin. Basically what this is saying is that I'm expecting 100 megawatts from you, increase in production, and I'm going to do my best to follow that, but if I reach my Pmax, I stop. So the rule is you're supposed to follow the participation factor post-contingency corrective response. If you cannot, you can only not do that if you've reached a limit on your generator's capability. Okay? You follow it as much as you can. When you have to stop, you stop. That creates a complementarity issue, and you can formulate this, if you choose to do so, as a mixed integer program. On the official website for the GO competition, there will be a formulation that shows this in multiple versions. You can see it with the mixed integer programming formulation or in other modes of presenting the mathematical program. Okay? But there's also a very simple approximation to this that's going to be in the formulation released within the FOA. It's going to be coming out soon. Every generator, every bus in the network has an infinite generator. So you can always assume you're in case 1 and then let your slack pick up the residual. That's another way of thinking of it. You'll get penalized, but that's one way of dealing with it, and then you don't have to solve a mixed integer program. That will be completely up to you. But as I said, reformulation of that will be presented in the FOA. All right, some more on generator contingencies. I talked about the real power response. Next, I'm going to talk about the reactive power response. This is, again, following with the traditional mechanisms that we use in the industry relative to pre- and post-contingency behavior corrective actions. This is a voltage set point rule, preventive and corrective actions. Voltage set point rule. I have instructed you to maintain your voltage at that bus at 1.06 per unit. You are going to follow through with that 1.06 per unit requirements as long as you can. Okay, so it's very similar here. There are 3 cases. You're going to maintain your voltage set point from the pre-contingency base case point in case 1, or you're only allowed to violate it if you've reached your Qmax or your Qmin, case 2 or case 3. So something happens in the network, my voltage starts to drop, I start injecting megavars into my bus to keep the voltage where it needs to go. But if I can't maintain that 1.06 level of voltage at my bus because I reach my Qmax, then I stay at Qmax. This is known in the power systems community as what's called PVPQ switching. It creates a complementarity issue again in a mixed integer programming formulation if you choose to model it as a MIP. Okay? So I'll just repeat that again. You're instructed to follow that pre-contingency voltage set point as much as you can in the post-contingency unless you reach a limit. Now, in your optimization problem, you can optimize what the voltage set point is in the pre-contingency state. But then moving from the pre-contingency state to the post-contingency states, you must follow this rule. You're in one of these three categories, okay? Transmission line limits are going to be represented, I'll take a pause actually. Are there any questions on post-contingency modeling? There's more information than, again, what is being presented. There are more precise rules in terms of regional response. In large power system interconnections, not necessarily is every generator going to respond. It may just be a subset relative to a region or a zone. Okay, so you're going to find additional rules associated to that in the official formulation. All right? Note, if there are no questions, to continue, transmission line limits will be represented based upon AMP current limits. That number can be based upon whatever. It's not really it should be much of a concern. It can be a transfer limit, a thermal limit, a proxy transient limit, or a proxy voltage stability limit, but you're going to be given that number, and you're going to have to impose it in a current form. We're going to use rate A for the pre-contingency first stage problem, rate C for the second stage post-contingency problem. You're going to get that information in your input data set. Transformers, we have 2-winding transformers, no 3-winding transformers. There will be MVA ratings on the transformers, not AMP ratings, okay? And we're not at this time for challenge 1 involving transformer tap adjustment, okay? Load modeling. We have fixed real power and reactive power loads. We do not have constant current loads. We do not have constant impedance loads. Some of these assumptions, I'll note, are likely to change for a future challenge. But for the first introductory challenge associated with the OPF, we're not getting into more of those issues. Likewise, here is the same comment, shunts, the modeling of your shunts. Okay? Fixed shunts will be identified. Then you're given an impedance. So there's going to be an impedance attached to that bus. And then you're going to choose the voltage output, which will dictate then the amount of MVA that gets injected, but you're going to have a fixed impedance. And then there are controllable shunts, which basically were relaxing that shunt and more so into an SVC, where there's a continuous controllable impedance of that shunt instead of having switchable shunts, which would then be a discrete mixed integer programming formulation. Okay? And then you have the capability to control in the pre and post contingency states the settings of those shunts. This is basically, for the OR community, this is again a reflection right here of a first stage and a second stage problem. This is a 2-stage program with recourse decision variables that you can optimize. Phase shifters and facts. Basically, we're not taking these into account at this stage. There are a lot of different ways of, a lot of different types of facts and also phase shifters, but in this stage, they're not being incorporated. So, with that, that's an overview of the simplified formulation. As I mentioned many times before, these are the key features that we're going over, but you definitely need to go to the official website and see the official formulation. As of right now, it's not posted. It's going to be coming soon. But you can get a taste of it from the FOA that gives a mathematical program formulation of the things I discussed here primarily in the FOA that will be released soon. Okay? Questions? Yuri.
Will the test code be released?
Will the test code be released?
The one that you're going to be using for testing.
Okay, so how are we going to evaluate your software? Great question. The answer is yes. So you're going to submit your algorithm to us. We're going to run it. We're going to use our own code to evaluate your software and then produce the score. We are going to, is that your question?
My question is whether you're going to release the code.
We're going to release it to you so that you can test our code on your own time, on your own computer, with the data sets we release in advance, so that you can see how you're going to perform under our criteria. Maybe you find a bug. If so, please let us know. Okay? But I don't think so. All right? I hope not. Okay? But we will be releasing the evaluation software for the competition. Okay?
The source code of it, or?
The code. The exact code. okay?
If you have multiple instructions on how to handle things, for example, complementarity constraints or
Do we have multiple instructions on how to handle complementarity?
you said you had multiple ways of doing it, right? So will your code account for it, or it will be only one way?
Our code, our evaluation code is not subject to that.
Okay.
You're going to be giving us a solution.
Okay, so
And we're going to be taking your solution and applying it directly to the mathematical expressions in the formulation.
okay.
Okay? We don't have to solve it for you. You have to solve it for us. Okay?
What I meant to say, it would be useful to have. What I think would be useful to have is to have like not only the formal description of what you want to see in our codes, but also to see how you want to have it implemented, to have a reference.
You can implement it however you like. What I'm suggesting, Yuri, is that we will provide you a few examples. So instead of giving an abstraction that this is a complementarity issue, or I just list option 1, option 2, option 3, we are going to formulate it as a precise mathematical program through a non-convex mixed integer program formulation. We're likely to formulate it in something else as well. Okay, you want to formulate those complementarity issues, you got to use big M reformulation of it with the disjunctive constraints that you have to put together. Okay, you're going to see something of that form come through. It's not going to be in the full release. We've already written it up to some degree. It's going to be in the official formulation. So you're going to see multiple versions so that we communicate to a broader audience. Again, we want to communicate to the broader audience the problem and not just limit it to people who already know the issue. And so, frankly, if you think that, it'd be great if you also present it with this perspective, by all means, give us that feedback and we'll consider it. Mustafa?
So the only recourse action that we have on stage 2 is the controllable shunts, right?
No, I think there's more. There's the mapping associated to the real and reactive power response. They have those complementarity issues. You have to choose associated to that. Okay, so there are constraints binding them to the pre-contingency, right?
Correct.
But you still have second stage decision variables, absolutely. Okay? Ignacio?
The participation factors, are they fixed or?
The participation factors will be given to you. We will tell you what the participation factors are. And they're not decision variables. They're fixed inputs. And we tell them we'll say this is what it's going to be. One of the let me give some more context in terms of the competition in Challenge 1. One of the things we decided is that we want Challenge 1 to conform as best as we can to what industry needs today. And participation factors are a dominant way of handling this challenge, okay? On the other hand, participation factors are an estimate. They're not precise. Future challenges will likely look more towards, well, that's one way of handling it, engineered judgment as to what we expect that unit to respond. I put it in my optimization problem and I find a solution that will conform to my engineered judgment. We're going to open that up in future competitions, most likely, to then be able to say, okay, what if you had free reign to redispatch your unit relative to your ramp rate across a time limit to activate your contingency reserve? What if you had faster response associated with voltage control set points? So that will likely introduce more more recourse decision variables that you can optimize in this two-stage problem. Other questions? No? All right. So before I move on to the next section, I also want to, we're going to be taking a break, actually, I almost forgot. But one thing I want to mention, the very first data sets we're going to be releasing are going to be smaller systems, 500 bus systems, 1,000 bus systems, 2,000 bus systems, and ranging in contingencies for each system, a few hundred contingencies, a few thousand contingencies. In the final competition, you should expect a problem that you have to solve the size of PGM, our largest RTO, 15,000 nodes, 10,000 contingencies. That's not an easy problem.
Just to mention the contingencies, can we use the parallelization for solving contingencies or any part of the solution process?
As long as our hardware platform allows for that, yes, and we want to encourage that because you should be able to do that, because if you create a decomposable structure of this two-stage problem, which I would think you probably, some people would, The contingencies are relatively parallelizable, right? And we should exploit that, because that should probably be where the state of the art is, and you should have the opportunity to do so. If we don't have that opportunity, Erminio, email me, okay? Because that should definitely be a part of it. Mustafa?
So has the hardware changed since the last description that was on the website? Because
Has the hardware changed since what was supposed to be previously? I believe the answer is no, and Steve's confirming.
So then, there is some opportunity for parallelization, but not much.
Okay, so the question is there, the point is there's not that much opportunity for parallelization. I will mention again, we want this to be a successful competition. We want to accommodate the competitors. If you really need to do this and add this to your software, or you need to change your hardware to accommodate that, we want you to contact us. We want you to make a good case for it so that we accommodate your request, make a good, strong case for it. But we are very much interested in making accommodations as best as we can, so this is as open as possible and really drives at the heart of finding out what is truly the state of the art, what is the best approach. So, if you think that there's a fundamental issue, you bring it to our attention. Steve has a point.
Right now, we're set up to work with the single node. We believe we understand how to use multiple nodes in this environment, but we haven't done it yet. So if you want to go down that path, talk to us sooner rather than later so we can work out the issues.
Okay, I think it's time for a break. We're a little behind schedule, about 10 minutes behind. So I would ask that if we can take like a 5-minute break. We'll begin again in about 5 minutes. For anybody listening online, please, 5 minutes, we'll be back, okay? Thank you.
I'm sorry, since they're giving us their evaluation software, we might be able to
That's what we have that we own.
They're just kind of following.
I all got.
I have big trips.
Your web station.
All right, if we can get everybody to come back in, take your seats. Please take your seats. We're going to start again. Our next speaker is, again, from our team helping us host this competition and putting it all together, Olga from PNL. Thank you, Olga.
Thank you very much, Corey. Good afternoon, ladies and gentlemen. My name is Olga Kuchar, and I am from PNL. I lead the team that creates the front end of the website, which you will be interacting with the most. So I look forward to your comments and suggestions as you start using our website through the competition. You've heard my colleague Steve Albert talk a little bit about the front end, the back end, and kind of give you a little bit of an overview. I'm going to dive further in. There are going to be documents, and then eventually a video will be available where you can just kind of look at it at your leisure and be able to follow the process of how do you register, how do you create a team, how you make a submission, what to expect, etc. But today is just a brief overview. So how are you going to make a submission? What you'll need to do that? What can you expect from the platform once you have made a submission? You will notice, first off, that my slides are a little bit different than what the gocompetition.energy.gov looks like today. That is because we are in the process of releasing a new version of the Go Competition website that will be available probably within the next week or so. So my slides are geared towards the new platform. So this will be, as Corey mentioned, your main source of information for the Go competition. We encourage you to register. That'll allow you to receive notifications as things are being updated, and it'll keep you informed about what is going on. Now, the first thing has nothing to do with our own website. The first thing will be for you to get acquainted with GitHub. GitHub will be your code repository for the competition. Hopefully many of you are already familiar, but if not, I would suggest to create an account. They have very good documentation. That is where you're going to be putting up your code, and that is where our platform will be pulling the code from. You can create both either a public or private account. The main difference here is public accounts, the code is available, others can see it. You might not want that, especially in competition, so you will probably want to create a private account, and that is truly private. You allow access to only certain individuals on your team, for example, that can put their code up there. So I highly suggest that you go register, try it out. If you're not familiar, get familiar with repositories and branches. All of this will be needed for your submission. Once you've done all that, and you've registered on the energy.gov website, then you want to go ahead and create a team. A team can be one person or many people. We do require that your team, each person on your team, register for an account. But you will create a team, and we really do not want you to share your Go Competition account with others on your team. Once you've logged into the Go Competition website, you will see a Create a Team link on your My Account page, and the team lead will create the team. And some of the things that we ask for are like a team name, of course your GitHub username that you've created on GitHub account. Then you select your team members, and then there's some other little check boxes that we'd like to just know a little bit more about your team. If you want to stay anonymous on the leaderboards while you're trying things out and you're not sure, if you're at the top or at the bottom and you don't want anyone to know yet, you might want to stay anonymous. If you are funded by the ARPA-E FOA that is coming out here shortly and you win the FOA money, please make sure that you do check that box because we want to make sure you are categorized appropriately. And then we will also have a competition ID that you will be assigned. Well, actually, ARPA-E will assign that to you. The thing is here to remember is you need to create a team on the Go Competition website, and there's actually going to be official paperwork that ARPA-E will require you to fill in. That paperwork, once it's available, will be on the website for download along with the instructions. So it's a two-step process. You need to fill in the web form on our site and fill in ARPA-E's form as well. You can always create the team and go ahead and play around, etc., but you officially cannot win any money unless you do the official paperwork as well. So I want to make note of that. Once you've submitted your team for approval, it's not immediately, yes, you can go and do this. It actually goes through and has to be approved by an admin on our site. Once we have approved your team, check the information, you will get an email notification saying that, yes, your team is approved. All the members on your team will get that email notification, and then any member on your team can submit for your team. So it's not just the leader. If by perchance you get an email saying, hey, you've been added to this team and you don't know who that team is, please contact us immediately that someone made a mistake, and we want to make sure we rectify that situation, because each entrant can only belong to one team at a time. So you cannot have a person on multiple teams during a challenge. Any changes, so you may add or delete folks from your team. Any changes also will require you to fill out official ARPA-E paperwork. So just a heads up that there are legal requirements, especially when there's money on the line. So once you've gone through that whole process, you've set up a team on our website. When you set up a team, it'll come back approved. You'll get an SSH key, a secure shell key. This is that encryption that Steve talked about earlier. And so your team page is going to look like this. On the left, there will be a huge or a long string of characters that needs to be added to your GitHub account. So what you do is you log into your GitHub account and go into Settings. Once you click on Settings, you go into My Profile. Once you're in My Profile, on the list, the menu list on the left, you'll see SSH and GPG keys. You click on that. That'll take you to another page, and there are two types of keys on there. You'll want to go to the SSH key and click on the Add New Key. That will finally take you to the screen you really want, and you give it a nice friendly title, something that you can remember, and then you paste, and we have a convenient copy SSH key button there, and you paste that key into GitHub. You add it to the account, and that allows the back-end platform of the Go competition to use its private key and grab the code from your repository for the submission that your team is doing. Are there any questions at this point? As I said, all this information will be available on the website, so you don't have to remember it today. Now you're all set. You can now make a submission to the platform. So you log in, and there are many different ways of submitting. There will be a link on the My Account page, which is usually the landing page when you first sign into the Go competition website. It will also be on the home page. Once you've signed in, you can submit to different parts of the challenges or into the challenge itself. Now, we do have, currently we have one, and with a new release, it'll be called Sandbox. There is a sandbox area in which you can actually go through this whole process. And at the bottom of that, you'll see a Submit button. That will take you to the submission page. And you enter a few pieces of information for us, like you might want to give it a submission name, something that makes some meaning towards you. Submission notes. You might want to make some notes about why this algorithm is different than maybe your team member's algorithm, or it's an update to another algorithm that you did, something that you can remember. Then you tell us which repository you want us to pull the code from, which branch you want us to pull the code from, the language environment, and in the sandbox you actually get to pick a data set. During trial 1 and 2 you won't be, but in the sandbox you are, and then you make that submission. At that point in time, the front end will send in all this information to our platform on the back end, and the back end starts processing. So it does not go into a black hole. You actually do get a lot of information back once you've started this process. you actually will have a submission summary page, which looks like this. And there's the information that you initially put in onto the website, so you know what submission this is about. And here, you'll see messages coming from the back end of where is your submission in the process. Is it still queued and waiting to be run? Is it already in the evaluation stage? Is it in the scoring stage? Or is it all done? So you'll have submission results. While it is running, there will be, instead of these boxes here, you'll have a terminate button. If you by perchance realize you made a mistake and it hasn't started running yet, or maybe it's just in the beginning of the process, you can actually terminate your submission. But when it's all done in that area, you will find a place where you can download the tar GZ file that Steve talked about from the back end that gives you a lot of details about your submission. A lot of CSV files, log files, and some of the information. They do go down to the scenario level because a data set may have multiple networks or models which might have multiple scenarios in them. And so you will actually get information back on a scenario level, such as the objective value, the violations, run duration. And you'll also get a list of directory folders for each scenario containing the Solution 1, Solution 2 text, the scenario submission logs, and more execution log. So you will get a lot of information back, which will help you hopefully understand how you did. If there were any issues with your code, what were some of the issues, what were some of the errors coming back. Now, you've already heard a lot of this is still in flux and still changing. Please check the website for any official updates on the formats. You also heard Corey talk about leaderboards. This is an example of a leaderboard that we are working on, not yet viewable. And it will give information all the way down to the scenario right now for the sandbox. As Corey mentioned, we will be changing those and only have them division specific once the challenge has started. Again, watch the website as things are changing. So I know that's a lot of information. You don't have a computer in front of you and following me along while I'm talking about all of this. So I do recommend everyone, please, if you're interested, you don't know if you're going to participate or not, please go and register. Please go and play in the sandbox. Create the Go competition account. Create a GitHub account. Try a submission. We have like an IEEE 14 one scenario case just so that you can play with the platform. I can tell you up to now, no one has been able to do this successfully on the first try. So it is a learning experience on both sides. Please make sure that you do take the time, and now's the right time because the challenge hasn't started yet. Of course, I'm very interested in feedback. If there's something that you like or don't like, I would like to know about it. Our goal here is to make these challenges fun, exciting, but give you also good information and a great user experience so that you will continue to participate. I can't do that without you contacting us and letting us know how we can make that better for you. Also, please stay informed. As Corey mentioned, the website will be your main area of information. So there will be a lot of information continually being updated. We do have forums that have many different topics on the website. And then we also have a contact us. So you can reach out to us. I wish you all the best of luck in the challenge. If you have any further questions, please go to the website, or you can also email us directly at arpacomp@pnl.gov. Are there any questions at this point? Yes.
Thank you. How does the choice of language or environment in the submission affect the runner? Like if we gave you a binary and a Python script or a mix of languages, would that still work?
So the main what is how to start off your process. That's pretty much where we want a starting point. So we know that we have all the correct libraries in the Docker container so that the environment is set up appropriate for you. Does that answer your question?
I suppose. I guess will you provide a list of the libraries or packages that are in each of the Docker environments?
Yes, so that's already on the website.
And again, if you have suggestions, by all means, provide them. Okay, so if something is not, is going to be a disadvantage to you in terms of your approach, bring it to our attention, and we're going to do our best job to accommodate that. So that's one thing. Another thing I want to say, I think it's also very important, the website, you will be able to take your algorithm and submit it as many times as you like to the website. So you can submit, actually even today, even though it's not geared towards the final rules and the structure of the competition challenge 1, but you can submit today, tomorrow, the next day, and keep doing that. So you can continue to evaluate and fix issues that may come up that are not on OPS solutions, but also improve your algorithm. And we want you to do that. We encourage you to do that. For the trial 1, trial 2, and the final event, of course, you get 1 submission, but continuous testing on all of these issues, from that to also the algorithm, are strongly encouraged. Any other questions? All right, then we're going to move right along. Thank you, Olga. I will be up giving some more background on the structure. The next section is going to be on scoring. How are we going to evaluate your algorithm? What is the judging going to be based upon? One thing to note is there's no human intervention whatsoever involved in the scoring, in the sense that you submit your algorithm, we get your solution, it gets sent to a evaluation software, the one that we're going to make openly available to the public, and out of that comes an answer, okay? So what are we concerned about? Well, the cost of the solution, the objective function, time to convergence, and constraint violation. These are our main key features. We want a fair and transparent evaluation of your approach, of course. It's not the easiest thing to come then to a scoring methodology that covers all of these different features, which is why, of course, we came up with 4 divisions. But let me give you some background information a bit more. We have some terminology that we'll go over quickly. We have what we're going to have power system network models. So, for instance, the data sets that are generated from grid data, we'll take Team A. They're going to create for us a 5,000 bus system. Let's say it represents the state of Texas, okay? So that's going to be one single power system network model, and that single model may have multiple scenarios. There can be variations on different aspects associated to that, loading issues, topology, whatever. And then a collection of those models and scenarios is then what we refer to as a data set, and this is important when you're going to see in the next couple slides in terms of how it affects the scoring, okay? And then, of course, there's a score per network model per scenario, all right? So we're going to first talk about the objective function scoring mechanism, which is related to lowest cost as opposed to performance profile, and then we're going to get into that following. Okay, so as I was just describing, you have a network model, you have a scenario, and you also have an entrance. Okay, so C here is supposed to represent cost. This is the cost that you achieve for a particular scenario for a given model, M, and then there is then the power system model, M. So model M is a network model. It can have multiple scenarios, S of M. And then tau represents entrant, the entrant tau. Okay, so there's going to be all these CM, SM, taus generated by our evaluation procedure. Okay, that's basically just the cost to operate that system for that single scenario, for that single model, relative to the entrance application. That's what the CM, SM, tau represents. Then you're going to have, of course, for Division 1 and Division 2, 2 different scoring mechanisms, one at a short time, 10-minute limit, and one at a 45-minute limit. And again, you'll be notified which of that, you'll get a solution for the real-time aspect, and you'll be providing a solution for the offline. And you're going to be, your program will be triggered as to which one we're asking for in both settings. Of course, the purpose of having 2 different time limits is, I think, as we know, there can be different performances across time. You can have an algorithm that does very well early on, but does not do well at getting close to the optimal solution, versus an algorithm that takes a bit longer to go, but does better overall in the longer term. We're basically doing 2 samples of this path. What, of course, you would want is a Pareto dominant solution that is as good and as fast as possible, but oftentimes algorithms do not behave that way. There are certain ways to approach it that are good and fast early on, or more of an exact method that'll get you close to the optimal solution. There may be infeasible solutions that you provide to us. Again, there are constraint relaxations that enable a feasible solution to always exist. But if your program crashes, can't handle the size of it or whatever, you get thrown into a bucket of basically infeasibility. And then you're going to get an infeasibility score, okay? Anybody that gets thrown into the bucket of infeasibility, you're going to get the same score as everybody else in that bucket. It was just going to be like worst case score possible. All right? Now, you have all of these models and all of these scenarios. How do you combine them together to get a fair assessment of the performance? We're going to use a geometric mean. We're first going to take your score per model per scenario for your entry, and we're going to take the geometric mean of it. That will produce for you a score per model per entry. Okay? So let me repeat that again. So let's say I have the state of Texas with 50 different scenarios. You're going to get a score for that whole network model across those 50 scenarios based upon the geometric mean of each cost for each 50 scenarios. That's the score M for model, tau for entrant. Then we're going to take another geometric mean. We're going to take this score M tau, and we're going to produce for you the final score for you as an entrant relative to cost based upon the geometric mean across the models. Okay? What does this do? Well, let's say, for instance, we have the state of Texas, a smaller system. Let's say we have ISO New England. Then we have PJM. PJM is much larger. It's going to have a larger cost. Okay? And so instead of putting the geometric mean across all of these, when the size of the models is going to vary, and the size of the complexity is going to vary, and the cost is going to vary, basically we're generating a geometric mean of each model first, and then equally weighting the models across from each other with the additional geometric mean on top of that. So what that kind of does is, let's say we have only 5 scenarios relative to PJM, but then 100 scenarios for a smaller system. It kind of pulls a little bit more of an equal weighting across these, even though there's less representation across the entire scenarios for the larger system. Okay? This is then going to be your final cost score for entrant tau based upon the first geometric mean and then doing it again across models. And that's what's going to count for Division 1 and 2. And Division 1 and 2, again, only varies based upon time. Okay? So that's Division 1 and 2 as an overview. I'll take a break in case there are any questions. All right, now we're going to move on to performance profiles. Again, the purpose of the performance profile is to get an assessment as to how often your approach gets a feasible solution and how close it is to the best solution. Okay? But the dominant feature, I would say, is really based upon the robustness of your approach. If you can't solve a problem and the operator is operating in the dark and they don't know if they have a valid solution, that can be much more problematic than getting a bad feasible solution. And the reason is because it could lead to a blackout. Okay? So robustness of your approach is very important. That's what we're trying to pick up here. All right, the performance profile mechanism starts with a ranking, with a ratio, sorry, okay? The best performer is the CM hat, SM. So we solve all of the entrants, we get the best CM, SM tau, okay? So the lowest objective function for a particular model, for a particular scenario, that goes in the denominator. Your score is in the numerator. Basically, this is a ratio of how well you did relative to the best performer for that particular scenario. If you're twice the cost, your R is 2. Okay? It starts there with that ratio. So we get your ratio for all of the different scenarios and models. They all have to be greater than or equal to 1. And then comes in this F and this function K. And this P tau of F. So F is this function, P tau of F, is an indicator function. And F defines a value. Let's suppose the value is 2. If you're within a ratio of 2 of the best solution, you get an indicator of 1. If you're within if your value is 1.5, you get an indicator of 1. If your value is 2.2, for an F defined as 2, you get a value of 0. So this is an indicator adder function that selects how often you're within a radius of F to the best solution across all scenarios. Okay? What then happens, where is it? Here. What then happens is that if F is very small, basically you only get the indicator if you're the best solution. So as you pull F back, only the solutions that are coming out to be the best out of all will get a value of 1. And then the items, this blue curve over here on the far left that's intersecting with the y-axis, that's the entity that had the most first place finishes. The highest value intercept on the highest curve on the y-intercept, okay? And then as you increase the value of F, you start finding that, of course, the functions grow. You're collecting information on how close you are to that best solution relative to the value of F, as well as having a feasible solution, okay? And so as F goes to infinity, if F were to go to infinity, basically all it's saying is, did you get a feasible solution? All right? F goes to infinity, it's only asking on feasibility then. Now note, if you have an infeasible solution to the relaxed problem, basically your ratio is infinity. So you're never going to show up for that scenario on this graph, for that one scenario. Your value is going to be always 0 for that P function, okay? And again, that's to the relaxed problem, not the actual SCOPF problem. So you create these lines, and then the performance profile mechanism operates by integrating over some given value of F. Okay? Let me go through that again. Let me choose F of 2. I'm going to take F of 2 and all of these curves, I'm going to calculate the area under the curve, and whatever is the highest value, that's rank 1. Okay? That then produces the best performer based upon some value of F. I'll get back to choosing F in a moment. But there's going to be a little modification to this in terms of how we produce rank 1, rank 2, rank 3, rank 4. Okay, so we start with everybody. They have these lines. We choose a value of F. We integrate. Largest one wins. That's rank 1. What we're going to do then next is we're going to remove team that won the first place, and we repeat the whole process. And then you get a rank 2 by repeating the whole process without the first place winner. Then you get rank 3 by removing the first 2 winners and repeating the process. And this keeps going and going and going until you get all of the rankings done. This will then define the performance profile winners. The reason we are removing the curve from the first one and repeating is that there's already been publications on this being a little bit biased towards against somebody who may always be second place. And there's a better way of doing it by basically removing these curves one at a time. Okay? That covers the performance profile mechanism. The value of F is also sensitive and can dictate who wins, right? So if we choose a very small value of F, then we are looking for people who perform not necessarily the most robust approach, but robust to some extent and also closer to the optimal solution. As, again, F increases, it's only caring more and more and more about only robustness. It goes to infinity, only cares about robustness. We haven't chosen an F as of yet. That'll be posted come the competition. Okay, any questions? No? All right. Coming back to scoring divisions for challenge 1. So just to review, we went over how the lowest cost is going to be determined across all the different scenarios and models relative to those 2 geometric mean procedures. That applies to division 1 and 2 for the 2 different time steps, and then the performance profile approach for divisions 3 and 4. All right. Questions? Ashley?
Can you submit multiple times for a score in the final event?
So can you submit multiple times for the final event? For the final event, you're going to give us your black box. We're going to initiate it, run it, execute it, okay? In that black box, you're going to have the option, right, of saying relative to an input that says I'm in division 1, 2, 3, or 4, how I run my algorithm. but you can only give us one black box. You're not going to have multiple submissions, okay? You're going to give us that black box again before you have any insight as to the data sets that are going to be provided as well, used, okay? So you're going to be blind to the data, but of course you're going to be testing over the data that we're going to be releasing before that. All right? Other questions? Dick?
Does everybody in the top 10 get 100,000?
As of right now, the proposal is everybody in the top 10 gets 100,000. Potentially there could be 40 different winners, or potentially there could be a minimum of 10. Okay? And then there's likely to be a challenge too. So let's say that I place very well in 1 and 2, right? Then I know I need to do a better job with my algorithm and robustness. Okay? And another way of looking at it is, well, the industry...
It's all one algorithm?
It's one black box, but in that black box you can put whatever you want in it, and then there's going to be a trigger that, we're going to tell you...
It tells you which one to do.
Yeah. We want a fast solution right now. And so you can allow that to trigger your mechanism to say, well, I'm going to take a heuristic, right, to make sure it's fast.
So,
Mustafa.
so am I correct to say, as long as you're within that 10 minutes or 45-minute time, doesn't really matter, right?
So the stopping criterion is time, right? We're going to take your solution, your best incumbent, once 10 minutes hits.
Yes, so it doesn't matter if I can solve it in like 30 seconds.
Doesn't matter. We could do 50 different time steps, but no, that's too much. We're doing two samples of your approach. Okay? Other questions? Another thing I want to repeat, there's a trial 1, trial 2, final. There'll be mirror images of each other. After trial 1, the data set that you did not see will be released so that you can see what you did well and what you did not so well. You're going to have the evaluation software, so you can run it on your own computer and then see, I got the exact same thing that was posted, or I did not get the exact same thing that was posted. I have a question, as well as to improve your approach. Okay. All right. No more questions. Yes, Dick.
So I may have missed this, but can I rearrange the topology of the network in my...
Great question. Can I rearrange the topology of the network? In challenge 1, we're not allowing changes to topology. There are changes that you can make to shunts, but basically not on topology. Basically, challenge 1 is more confined to general practices today, so that when you have your algorithm working with what they do, they will buy it. And then the hope is that again, opens up opportunities for that entity. And then challenge 2 is contemplated to be much more open, in the sense that let's talk about advanced power flow controllers, smart wires, transmission switching, stochastic optimization, other aspects that are more, say, future leaning. Okay? All right, eligibility and rules. There's a lot here. There's also going to be a lot on the website. The main issue that I will point to is if you want to win money, your team has to be led by a U.S. entity, a U.S. organization, a university, a private company, a research lab within one of the DOEs, but the entrant team must be led by a U.S. entity. Okay? There are more restrictions for the people who apply to the FOA that are in the FOA. But for the general entrant requirements, which basically includes the open, if I'm a researcher in the States, I'm a U.S. citizen, I'm leading my team, but I'd like to collaborate with people from Canada, that's completely fine. Your team has to be led by a U.S. entity. There are some other finer rules here in terms of, federal employee participation or not. The answer is no, at least not within your job description. Some other rules. What is very important, Olga mentioned a bit on this, each individual can be on only one team, okay? I can't be leading 20 different teams. So we are making that a rule that, again, you're going to have to choose what team you're on. You can submit multiple times. You can talk to other teams if that's what you want to do, but you can only be on one team. Every team has to precisely specify the people who are on their team. The 5 individuals all will have to submit 5 different signed forms. I am a part of this team. You can change your team members if you like. Then you have to submit an official form saying we are making this change, and whoever is involved in that change has to also sign and agree to it. But each entity, each individual can only be on one team. An organization like a university or a national lab, you can have as many teams as you want, but each team has to be made up by mutually exclusive individuals. Okay? You have to submit unique technological approaches. You can't let's assume that you're confident you have the best approach. You can't then give it to your friend and then have that friend submit it for you as well and take up all leader positions. Okay? We're not going to allow that. So each team has to have a unique approach, and if DOE, ARPA-E thinks that's not the case, we reserve the right to inspect your code and to figure that out. All right? So just keep that in mind. And you can be disqualified if you're found doing that. All right? Intellectual property and proprietary software. You submit your software to P&L, you should mark it as proprietary. Okay? That provides you protection. The proposal entrants, the people who are on that get selected to the FOA, they have different rules applying to IP and licensing that are the general requirements that ARPA-E always applies. Since we're paying you to participate, yes, there are some rights that DOE can receive. Those will be in the FOA. Read the FOA. Basically, for an open entrant, we're not claiming IP on your stuff. It's protected. It's your software. It's proprietary. We do not want to discourage people that have the best approach, that have their own small business, or a vendor that's already in the business selling their software to their people. We want to know what the best approach is. We want to make it open to encourage people to participate and not discourage. As always, this is a miniature version of the rules. Absolutely. There's much more. So you need to visit the website to learn more, okay? In summary, you want a modern grid, you need modern grid software. We're trying to overhaul our legacy systems that are out there today and bring in innovative solutions. This is very important, I would say, for all the emerging technologies we have in the grid space. The software and the management systems are a key issue to bringing in a technology like transmission switching or power flow controllers or many other aspects, okay? Another thing is the competition. Challenge 1 is not the only challenge. We are very hopeful and optimistic that there's going to be a series of these. So this is not about only OPF. This is much broader, again, about grid modernization and grid software. And we are really excited and hopeful with our mission that we start here. We can continue to break ground, to bring innovative solutions through to this industry to really make a big impact. To bring forward, as I said, those emerging technologies. That is the end of our primary slide deck. There's one piece of information that is not here I will share. You have any questions or comments, again, as I've been saying, you can go to the website. There's information on, the contact information is there. You can also email me. My email address is not up here, but it's just corey.hedman at hq.doe.gov. Long day. Sorry. So you can email me if you have any questions. Email the P&L staff as well. We do have some time remaining for questions as well right now, so anything is up, and we'll take your questions. Ashley.
What sort of sponsorship opportunities?
Oh, yes, I forgot about that. Sponsorship outreach to competitors, but also to the broader community. We want sponsorships. We want to engage with the community. So we hope to get additional funds outside of general ARPA-E, for instance, to fund international participants. So right now, as I said, we're working with a company in Europe that's maybe willing to give us some money so that they can then pay for somebody that wins in Europe, for instance, okay? So if you have any suggestions on that, or if you're personally interested, please please contact us. So that's one thing. The other thing is data sets. Most of the data sets used in the competition will come from the grid data program, where we are generating synthetic, realistic, but not real data sets. Those will be publicly available at some point in time through the competition website for the ones that are used for the competition. Okay, however, we are also engaging with ISOs, and we hope to engage later with other industry partners to get actual data sets from actual industry companies. We're working with one ISO already to achieve that. So if you're an ISO and you like this idea, you want to see how the best algorithms perform on your actual data, please get in touch with me. We're going to take your proprietary data, put it on PNL, not let anybody touch it. It'll be used only on the back end for evaluation for the final competition. It will never be publicly released. We'll get an NDA signed, go through all those procedures so that your data is secure, but we can use it for the testing. Okay? And then what you're going to see then is the ability to say, okay, this team performed best on my data. That's very powerful. We want to have that happen. All right? And second, let's suppose we have a large selection of RTO data sets that are actual operating conditions. And then our synthetic data sets don't show any discrepancy on who is the best performer on the synthetic versus the actual proprietary data. That's very powerful. That means that that synthetic data is a good reflection of reality. And that will help the power system sector immensely to know that this open source data is to be trusted and valued in terms of testing new approaches. And so that would also be a very big win. We very much want to get that. So please, for anybody that's going to listen to this or in here today, if you're willing to provide data sets from your company, we will go through the means to protect it, to not release it to the public. We'll use it only on the evaluation side within the platform, within PNL, but we definitely want that. Other questions? Yes?
For the instances that are publicly available,
are the same instances being used in scoring and training?
So for the instances that will be publicly available, there's basically going to be 4 dumps of, or at least 4 dumps of data sets. At month 0, after trial 1, after trial 2, after the final. Okay, so, and they're distinct. There may have some commonalities, like we may have a team creating a Texas system, and they give us 100 cases. We reserve 25, 25, 25, 25. We may do something of that nature, okay? But again, for trial 1, you will not know the data sets in advance. For trial 2, likewise, for the final event, likewise. The data sets will be released after those events, okay? Mustafa?
So I have 2 questions. First, you disqualified the teams that were on the grid data program, right, to participate in the competition. So do you apply that rule to organizations or individuals?
Okay, so there are a lot of people helping us run this competition. This is not a small event, and the question is, are there disqualifications for the people helping us? Absolutely. I cannot participate. The other people working for ARPA-E cannot participate. People at PNL cannot participate that are helping us. People that have their hands in evaluating your program cannot participate. Other people at PNL that have nothing to do with the competition, they can participate. A professor at University X that's creating data sets for us will be restricted, but some other professor that has no involvement with that professor can participate. You will find in the rules document and in the FOA that if you are in an organization that has an employee that's helping us, you must get a signed affidavit stating that you have had no involvement with the help of creating, running, providing data sets for the competition. So there are very precise rules that you need to look into if you're in one of those organizations. So for instance, again, PNL is helping us. Some other researcher at PNL can participate and can be eligible for money as long as they have no interaction and they get us that signed affidavit.
Second question, are you going to make AIMS available? So support for AIMS language?
Support for AIMS. Send us an email, we'll consider that, okay? Other questions? Dick?
I'd like to make a suggestion.
Sure.
I was reading something about this competition, and I saw Go competition, and I thought it was the game Go. I asked myself then, why is ARPA-E having a Go competition? So I mean, using grid optimization may be better than just saying the Go competition.
That's a good suggestion. I don't know the game Go, so we'll just take you back on it. Other questions or comments, suggestions?
It was the thing that came up. If you Google Go competition, it's an AI.
Didn't know that.
Well, they have competitions for the game of Go, like chess players and things like that. And so I immediately thought it was a.
That's a very good point, Dick. I didn't know. Other questions? Well, if not, again, email us, contact us if you have any suggestions, questions, feedback. We really do appreciate it. Thank you, everybody, for taking the time. We're going to end there. And best of luck to everybody.
You know, it's important learning.
Go.